Hello everyone and welcome. Have you ever looked at a chemical structure drawn on paper and wondered how it actually exists in three-dimensional space? Molecules aren't flat, and the way they twist and turn is incredibly important. Today, we're going to explore a fundamental concept that describes this 3D nature, the dihedral angle. Understanding this will unlock how we think about molecular shape, energy, and stability. A dihedral angle, sometimes called a torsion angle, is essentially an angle of twist. To define it, you need to look at a sequence of 4 connected atoms. Let's call them atoms A, B, C, and D. The dihedral angle describes the relationship between the AB bond and the CD bond as you look down the central BC bond. Imagine the first 3 atoms, ABC, form a flat plane. Now, imagine the last 3 atoms, BCD, form a second flat plane. The dihedral angle is the angle between that first plane and the second plane. A much easier way to visualize this is using a Newman projection. This is a special view where you look directly down the central BC bond, like looking through a telescope. In this view, the front atom, B, is shown as a dot. The back atom, C, is shown as a large circle behind it. The other atoms, A and D, and any other groups attached to B and C, are drawn as spokes coming off the dot in the circle. Now, the dihedral angle is simply the angle between a spoke on the front atom and a spoke on the back atom. This rotation around the single bond is crucial because it leads to different molecular shapes called conformations, and these conformations have different energy levels. When the groups on the front atom are perfectly aligned with the groups on the back atom, the dihedral angle is 0 degrees. This is called an eclipsed conformation. It's a high-energy, unstable state because the atoms are crowded together, causing steric hindrance. But if we rotate that back atom by 60 degrees, the groups are now perfectly nestled in between each other. This is called a staggered conformation. It is much more stable and lower in energy because the atoms have more personal space. The most stable arrangement is often when the largest groups are 180 degrees apart, a conformation we call anti. So, the dihedral angle isn't just a random measurement, it's a precise way to describe a molecule's 3D shape, which directly dictates its stability and reactivity. Thanks so much for watching. I hope this explanation helped you visualize what a dihedral angle is and why it's so important in organic chemistry. If you found this video useful, please consider giving it a like or subscribing to the channel. Your support is greatly appreciated and helps me continue to make more educational content. See you in the next video.